Okay, as you are aware, I'm sure, you'll know that oftentimes one thing leads to another, and which brings us to laser cam with Fusion 360. So this is a cardboard box that that I wanted to make. My wife sells quite a few things on eBay, and oftentimes she has trouble finding a box that's just right. It'll either be a little bit too small or a little bit too big or maybe way too big. So I thought to myself, I have a little hobby dedicated laser machine. I can make these boxes. Well, when I say little, it's little. If I show you the size of this box, when it's folded out flat, the sheet of cardboard that's needed to make this box, you'll see here, is pretty big. The box itself is only 8 inches by 8 inches by 4 inches deep. But the piece of cardboard we need is over 33 inches long. And let's see, the widest part is here and here, of course, over 12.5 inches wide. So that's a pretty big piece of cardboard, and that won't fit on my little hobby laser. But hey, I have a big CNC machine. I can fit a laser module on that, and I can make a cardboard box. So that's what led us down this road. What led us to Fusion 360 was a couple of things. Number one, I waited too long to buy Lightburn, and the price went from $60 to $99. Now, let me say that it's worth every bit of $99, and you'll see that based upon how difficult and how many features Fusion 360 lacks relative to hobby style lasering services. So if you're making, if you're just cutting out parts, Fusion 360 is great and it'll work good for you. But if you want to make designs and ornamental things and you want to put fancy text, and sometimes the text will be outlined and sometimes it'll be filled, and Fusion 360 just does not lend itself to all those sorts of things. It just doesn't. So let me show you this process and what's involved with taking your machine that's simply a CNC machine, milling machine, and being able to cut out and score the cardboard or whatever projects you're trying to make. But in my case, I needed to score so that the bends would fold and bend without tearing and without, looking crazy. So here's our flat pattern. First thing we need to do is create a setup. So we're going to do a new setup, and we'll choose our machine. And I'm going to choose a local machine. And now, as you may or may not know, Fusion thinks about things in certain ways, especially what type of process it's getting ready to do. So it might be doing milling, it might be doing cutting, it might be doing turning, and then of course additive processes like 3D printing and so forth. But it considers laser jobs, water jet, and plasma type jobs. It considers those cutting, and so my machine is set up as a milling machine. So here's where my machine should be, but I can't even find it. It's not here. So let's go in and look at the machine and see why. So here's my machine. If I edit it, I can see that its capabilities are milling. But Fusion calls this cutting. Laser jobs are cutting. So I have to add that capability. That's the first step. So once I add the capability, then when I want to do a new setup, I can select my machine. Yay, here's my machine. It can do milling and it can do cutting. So I select my machine. I've got my point set up. My model is set up. The rest of these parameters don't matter because the other thing Fusion assumes is that all these types of processes are 2D processes. So you don't need to move the z-axis at all for this stuff. And so my setup is done. Now I am going to create a toolpath. And let's select a tool. So my tool for cutting is the laser. So, oh boy, how do I do that? I look at my library. I don't have any cutting tools. So I'm going to select laser cutter. But how do I get that in here? Can I drag it? No. So what I need to do is I need to go to Fusion's library and I need to find the tool and copy it into my local library. So there's a laser cutter, right? Inches, metric, choose your poison, copy it into the local library. All right, so there's my laser cutter. I'm just going to edit it to make sure that the properties are correct. I can give it a name. Laser Tree is the manufacturer of the one I purchased. Cutter, the kerf is 0.1, not 0.4. So I will change that. And then the rest of the stuff doesn't really matter. I will accept that. The next thing you need to do is look at these presets for the laser power. So here is feed rate of 100 millimeters per minute and power of 800. So my power is range is from 0 to 1000. For this process, I'm going to want to use a power of 100 for the well, let's set up a cut process, and then we will also set up a score process. And the score process will be 100. And I'm going to do a speed of 500. Okay. And then the cut can stay at those settings, so we'll accept that. And of course, if you don't know these settings, you're going to have to test them and make sure you get them right for the material in your machine and all that kind of stuff. But I'm sure you already know that. If you're doing laser jobs, you already know that. So I'm going to select that tool. And now these things have all populated. And so let's set up our first tool path. And what I'm going to do, I'm going to do the score first, and I'm not going to try and select all these lines because that's just not worth the time that it'll take to get this done. But let's just select the innermost path here. We've got 4 little chains. And of course, like I said, the rest of these things don't matter for this process because we're just doing a score. We're not, it's all just 2D. You want to make sure you're only doing one pass. And that's all fine. So we'll select that, and while that generates, I just want to take a minute to say, if you like this video, if this content is helping you in any way, and you see your way clear to, hitting the like button or subscribing, that'd be super great. So there's our first toolpath set up. We're going to do another one, another 2D profile, which is the only option you have in this in the cutting process. You can't do anything but a 2D profile. So earlier in the video you saw where I made that little sign and I did some fill in on the letters. What I did was I used the offset tool, and I offset the shape of the letter inwards 0.1 inches at least 1 or 2 more times on each letter to kind of give it some filler, and which is something that you don't have to do with Lightburn or some of the other softwares that operate laser machines. They have this feature to fill it, and you can set the density of the fill, and you don't have to fiddle around with the shape or the model or the text or the geometry or anything. It just works. So anyway, I've selected the outer profile for a cut, and at least Fusion has been able to select that without me having to hold its hand, and it looks pretty good. So we're going to select OK for that and let that generate. And that's all generated. So let's take a look. We'll simulate our first toolpath and see, it's not going to be very exciting, but the simulation tools down here, here's play button. You can change the speed up and down, and it's going to show you what it's going to do. This is really handy if you're doing more complex cuts, and especially anything three-dimensional. You want to run this simulation to make sure that what you think is going to happen is what happens. So the simulation dialog here has a lot of settings that you can turn on and off. You don't have to look at the tool if you don't want to. You can have the tool be transparent or solid. Lots of different settings. You can play around with those and see what you like and what you don't. So that looked fine. I'm assuming that the outer profile cut is also going to be fine, but we'll quickly simulate part of that just to make sure that looks okay. And then lastly, we will just generate the G-code files that can be used in a G-code sender, such as Universal G-code sender or Laser GRBL or any number of other ones that you might choose. So that's good enough. We'll exit that simulation. And what I like to do is I prefer to generate 2 files, one for each process. You can just generate one if you want, but my preference is to generate 2. So if I click on here and I say create the NC program, that's what's going to happen. Give it a name such as box scores. And I don't know why you have to give it the name twice, but you do. And you can tell it where you want it to store it. And the last thing that got me the first time I did this, and you got to be careful of this, when you post-process this, you can't use your standard GRBL. You have to change it to laser GRBL. And if that isn't in your setup, you may have to add that. This process is just as easy as hitting post right here. I'm going to go ahead and cancel that. But if you want to look at your process, your post library, just take a look at that. And so my local post library, there's nothing in, but my cloud library, notice that there's Gerbil laser and there's standard Gerbil. So you want to make sure Fusion has it in its library, but you have to add it to your library such that you can select it when you post-process. And that's kind of it. I'm going to wrap it up here. I tried to keep it as short as I could. Once again, I'm John with Beechwood Craft. Thanks for joining in. I hope you enjoyed the video, and come back again. There's going to be some more interesting content. Hopefully, some more woodworking and less computer stuff. But have a great day. See you next time.